Good morning. We're back live. Hi. I'm on a bit early today. May I be forgiven for skipping leg day? At least temporarily. uh, okay, let's take a look at some of the experiments that we ran overnight. Looks like it crashed at 167, so that is odd. We will check on that. Looks like we have a number of reasonable runs here. We check score. Low is 45 mil for a solve. And then, oops. Got relative times that are about 23 seconds or so, 25 seconds for a solve. Pretty good. Pretty good. And then before we go into the actual real analysis for this, oh, yeah, okay. That's pretty damn good. So our sweep algorithm is really doing things once again. These are quite nice results. Almost 80%. So I think then what we will do today, we're going to start off with a bit of analysis of these experiments. We're going to see if optimal hyperparameters have changed quite a bit or not. See what has happened in that area. And then we will see where we go from there. A lot of different potential things to do today. I've not actually used this interface in quite a while. Good to be back to this. So yeah, here, if we see this chart shows us how well runs we're doing over the course of the sweep. You can see we get some middling ones early on, then we kind of latch on and they get really good by the end. We're still running a range of different costs of experiments, which is what we would want. Good. Total time steps ranging from like 40 something mil, or no, 50 something mil up to 100 mil. And with batch sizes not really being explored very much, which is a little odd. I'm just looking if there's anything super weird here before we go to the other view. Up here. Lambda, we've got horizon, num-ems. We didn't sweep this at all intentionally, so this is going to stay here. And yeah, then costs are actually quite well distributed. Okay, we get value coefficient. So these sweeps all look reasonable. Now if we can get the, where is it? Sample, this one. This is going to show us like hyperparam robustness. So this looks quite good, right? That we have these runs we can solve with a pretty wide range. But, you know, I think I want to filter this to be under 40 seconds maybe. Because the thing is, like, you could have really good runs that still just take forever. So why don't we filter this to be, I think that there are plenty of runs here under 35 seconds, right? Even under 30 seconds. No. Because they take a while to eval, so we'll do 40 seconds. So we'll just do like time. less than equal 40. One item. Really? Huh. We'll do 45 since there's a startup time with this. All right. 97 results that are less than 45 seconds. Let's see if we're happy with this filter. I think we could be a little bit more aggressive on this, right? I mean, it's kind of hard to say because some of these evals are so long. Maybe we'll go with this for now. Okay. MIT has finals this week? No idea. MIT is semester system, I believe. Stanford is quarter system, though. Their schedules are a bit different. I much preferred the trimester system, I will say. Like the quarter system. Semester is just too long. Like if you get behind in anything on week 8, you're screwed. Okay, so this still looks relatively like stable. And like the gamma range is still relatively stable. And lambdas are so like this is confirming what I was thinking of. Like it seems like the hyperparam ranges are just way more stable than they used to be with the new optimizer and all the new stuff we've done. There are some new parameters we have to check. Okay, so here's atom beta 1. Again, we're getting good runs anywhere from 0.9 to 0.98. Beta 2. This one stays quite high. Yeah, so we're seeing like not much dependence at all on these. Let's add some new scatters for the new metrics. Bio alpha. And then this will be train total time steps. Why does this not have, yeah, there it is, last 4. So here's prio alpha. I totally messed up this axis, hang on. The x-axis should supposed to be alpha. There we go. Doesn't look like there's a huge amount of dependence on this. We didn't really expect it to for this env. And interestingly, there doesn't seem to be very much dependence here either. You solve with both. That's kind of weird actually, because these do very different things. Well, I suppose what we can do now, right, is we can really just tune this into like we can go like 40 seconds. Okay, so now we're at 65 items. These are now like the better experiments. We still don't really see any dependence. Kind of anywhere. So I guess it means that like any of these hyperparameters individually can be robust. So like kind of any value of any of these hyperparams individually is not enough to break it, which is kind of weird because this is definitely not how RL worked a few months ago. So this has got to be a result of all the new tuning that we did. I mean, all the new algorithm stuff that we did to enable the tuning. It's quite good. So what I think we do next is let's pick like a few good runs that we know we like here. Actually, I don't necessarily even want this filter anymore, right? Yeah, because like there are runs up here or whatever that they stretch farther. So this one is good. I really wish you could click on a run. Can we get that Neptune? It's like very silly that we can't do that. Like there's not a good way to sort through these at all. Well, I found one. This is one run, 27,346. Here's what we're gonna do. 27,346. This is a very good one, right? 60 mil? 20 seconds. So this is the right one. And we have, I guess there's like this purple one underneath of it that looks pretty good. Oh yeah, there's this green one here. It's like lime green. We probably want this one. Yeah, it's this one, 27,385. Okay, so we get two different runs here. The purple one actually looks higher in this. This one's good as well. 375, 27,375. I'm just trying to get like a few of the better runs here. And let's get like one more. I guess this one's good enough. 27,371. Just a little bit under, yeah. Okay, so these are the runs we're going to pick for our little bit of analysis here. And I just want to see, like, of the top runs, kind of like what's the spread in hypers. Because, like, the idea is any of these do pretty well individually. So, like, do they have similar hypers? Is this still a range? Or what's going on here? And then we'll see if we can reproduce all of these, or if they're, like, tricky to do that. Okay, so learning rate anywhere from 0.1 to 0.17. So that's like a 2x range. It's pretty reasonable. Oh, I don't like this one, actually. Hang on, let's get a different run. I don't like this run that didn't quite converge. Get something better. We did this one. One page next. $27,346. Do we not have this one yet? We have this one. This was the best one. I wish this is just like a missing Neptune feature that should, like, you should just be able to click on this, or at least see the names correctly when you hover over them. This one's not bad. 297. And this converges nicely. Okay, cool. I'm happy with this. And you know what I'm gonna do? I'm gonna just post this real quick. So what's this? This is like 50x200. Is that 10 billion steps of breakout? Hang on. 50 mil, 5 bill, like 10 bill steps of breakout. All right. The learning rate here is anywhere from 0.01 to 0.017. You get like a reasonable range here. And actually, I'm going to take some notes down to like do these again, because this is kind of what I'm going to do for the final analysis of all this stuff for the release. You'll get a quick preview then of this. Pre-release analysis, run sweeps, ends, pick top, type best, curves, size, ram ranges for these. Probably do like breakout, snake, maze, all three, and like one more tower climb. Maybe something like that. We'll see which ones we use. I think that's going to be a good start. Okay. The learning rate has roughly stable regime factor of almost 2. Gamma is actually pretty tight. Gamma is actually pretty tight here. If you look at it this way, I guess we did only take like the top few, but like there really only are a few like really good ones in here. So gamma is constrained from 0.974 to 0.985. So there's like a pretty narrow range for that actually. We could also ablate these, right? That's actually another idea. Calculations on one time. I think we're going to have to do 2 M's for that. Maze. I'm glad I made that maze environment. It's been very, very useful. Okay, so lambda is way, way more robust, as we expect here. Right, so this is 0.84 to 0.96. Lambda doesn't really seem to matter that much. We did not sweep update epochs. Value coefficient is actually, these runs are all in a pretty narrow range as well, 0.11, 0.135. Grad norm, there's a bigger range here. And then entropy coefficient. Okay, it actually does get some entropy now. I didn't do this before, I don't think. We did not sweep horizon here. And then we have sweep progress. Oh, that's nothing. This batch size didn't get changed. Total time steps? Okay, this is interesting. Anywhere from 65 million to 100 million. So some of these would just be slower than others, right? I guess what we can do is we can like look. Oh, it's just the analysis at the end, you see? There's like this massive post-analysis. Like it's not really doing anything here. It's already trained. Yeah, so these are actually like, these are all done at about the same time, right? This is where they're done. And if we do like rel time here, right? If we do rel time and we just check here, they're done at 25 seconds. Definitely by 30. I am curious on, okay, they all use the same mini batch size. We did sweep mini batch size, didn't we? If I check mini batch. Yeah, we totally swept mini batch, right? It's just this is the best one. So it's up to 16K, which is twice what it used to be. In our old version, you could not get better than 8192 for breakout. So this is faster and better overall. One second. Okay. This tells a different story here, right? Now we have a pretty narrow range of atom beta 1, narrow-ish range, and atom beta 2. And the epsilons as well. Bio alpha. Okay, prio doesn't seem to be mattering a ton here or here. It's a little interesting. Little interesting how that works. I didn't expect it to matter a ton here, though. I'm a little surprised at how much it doesn't matter, but we will see. I'm not going to judge this until we see the maze results. The maze results are the ones where we would expect this to really matter. If it doesn't matter there, then something is up. Mind you, this prioritized replay is one small portion of the sampling algorithm, so. Okay, so a couple things we want to do here. The first thing is we're going to pick one of these. I think we are going to pick probably this dark one here, which is, what's this numbered? 27346. All right. What I want to do is first see if this run replicates appropriately. I really need to make a better way of copying settings over. So this thing actually has a ridiculously high learning rate now, right? I am curious to see if this works for other M's. This is like a ludicrously high learning rate. That is not changed. This is like maxed out alpha. Actually, that does... Wait, O? No, this is min alpha. Okay, that's actually interesting, right? I think I read the chart wrong then. Where's prio alpha? Two of these have min alpha. Interesting. I mean, that does tell you something, right? Because it's basically trying to not use this parameter. But the other runs where it is using it still work. Total time steps, we'll do 75 mil. So, doesn't really do any more sample efficiency, but that's fine. We did not tune it for sample efficiency. We do have the ability to tune for sample efficiency with the exact same algorithm. And then we did not sweep any env params. So if I did not miss anything here, this should work. Hey, welcome. How's it going, man? A Neptune key. Question mark? It's just not running. I don't know, something's weird. Wrong branch. That's annoying. Take all this. I've seen you in here. Welcome back. Okay, there we go. Now we just grab token and we see if we basically just see if this run matches. So 25-second solve on a slightly faster machine. We're training 2.3 mil steps per second. Yeah, so 26, 27 on the slightly slower machine, very reasonable. And then done training in 30-ish. Okay, those are good settings. Yeah, those are good settings. I guess, like, how robust is this thing? If I just, like, start grabbing parameters from other runs, like, are they all highly correlated or not? Like, there were training learning rates up to 0.17, right? So if I just do this, does this still train? Yeah, that's about the exact, like, almost exactly the same as before, right? Final eval's almost identical. And then if I go, like, outside of this range, maybe? I'm just trying to get a sense of how correlated these all are. There's probably a way better way to do this automatically, which I should do for release. Okay, so this does do worse, right? So if I go outside of the range of these sweeps, you see here, it's not like it's not working, it is working, but it's going to take longer. So anything in the range specified is fine, which actually is interesting because this range, like the low end of this range, is twice as high as I had previously. Probably because of the mini batch size. It doubles mini batch size, so it doubles learning rate. What about gamma? Like 0.985, does this do stuff? Yep, that works. Slightly lower. Are these general sweeps? You're trying to start to get a strong baseline? Captain, I'm trying to ascertain hyperparam robustness in general. So first thing is we didn't really do a proper sweep for the latest version of the code, so I'm doing that. See if anything has shifted. And then from there, we're gonna see like across different M's if the optimals are substantially different. So I have this sweep to analyze right now, and then I have the maze sweep to analyze. And we're gonna see how those two are different. Okay, so like this one was higher, right? 973. What if I do that? Maybe I just want to see how accurate these counts are. Like, does it go higher if I go towards this end of the param range? And I don't mind just playing around with a bunch of experiments when they're this fast, right? Okay, that actually replicates like really, really well. This is slightly better. Like if I were looking for defaults that don't look insane, right, I could do something like this. And then where's gamma? Where was it? Lambda? Four. What's this do? We're gonna just test like the major ones like entropy and stuff like that out. About the same. Is it robust in this range? Doesn't seem like it is. This is worse. If I restore this, we want to make sure we're not also just looking at seed variants here, right? We're not going to do this level of manual fiddling for the maze-emp that takes forever, but it is useful once in a while to like get a sense of how robust your RL feels. Okay, 860. So yeah, that is back to being correct. So let's see now if I just make a very small adjustment. So this will change like the seeding and very little else. I do 8.5. This should not have a big swing in it if we have a consistent env and a consistent training setup. And we are robust. So then I don't have to give hyperparam defaults to like giant string of digits. Okay, yeah, this is very consistent, which is cool because breakout didn't used to be. So this is very consistent. And the params aren't like, if you change it a little bit, it breaks. It's like, it's pretty robust now. Now, entropy. I'm actually interested to see entropy. This is way more entropy than we've seen before. Do I not have entropy on here? I saw it right there. Okay, so anywhere from O2, like O25-ish, all the way up to O54. So what happens if I use the... First of all, what happens if I do 0? Does this thing train without entropy? It's actually kind of better if it doesn't, because then we'll have this as a nice test end for like when we try to go replace entropy in the next algorithm block. We'll have something to go off of. Okay, you can see that there is a that's a pretty decent difference, right? I mean, they get to very similar places, but where'd the other curve go? Yeah, so this is the new one. Would it work if you made the entropy coefficient negative? I don't know. I could imagine that messing stuff up quite easily. The entropy actually made, like, it made it, like, these curves are different. It's not hugely important, but that is a distinction. That's not just random noise. Breakout isn't an env where you'd expect it to be super important, though. So it's going to be interesting to compare these results to the maze. I do want to paste this because I've got about an hour before breakfast, so I want to get both of these analysis results done before then. Okay, yeah, so it doesn't work with negative entropy because it just determinizes the policy, right? So, like, you get positive point, plus 0.05, 0, and negative 0.05. But now between the low end of the range here and the high end of the range, can we tell the difference? See. Low end is slightly better. Low end is slightly better, actually. Like, less exploration at the start, but better convergence. That's about what we'd expect. Keep this. In some sweeps, I did impulse wars train much better with very low entropy. Yeah, I mean, I've seen that too. It depends. Like, it depends. These things used to make no sense, and now they're starting to make more sense, right? The general vibe. Slightly worse. Yeah, entropy isn't really exploration, though, is the thing. I mean, it's like dollar store exploration. Dime store explanation. It literally just encourages the agent to flail about a bit. Like, it's not exploration in any meaningful sense of the word. So that made a big difference, actually. That little tweak that made a big difference. So this param actually matters. We go to 9.9. Well, that's interesting. This atom term, I bet I didn't sweep it fully, right? No, I have a max of 0.999 on atom beta 1. It doesn't use it, though. What happens if I go to 0.999? Does this, like, do worse or better? Okay, so this is worse, right? That's why it doesn't go above. Yeah, that param matters a lot. Atom beta, but 0.99 seems good. Max gradient norm. This one is potentially interesting, right? What happens if we clip this a ton? So if it's using this, okay, so clip frac here, it's clipping a lot of the updates. So we should suspect this hurts perf, maybe? Very marginal, if anything at all. Okay. 50. What if we're not clipping grads at all? Actually, that clip frac term is based on KL, I believe. Separate from the grad clip. Yeah, so this param like doesn't matter at all. So like highly sensitive. We know this one's highly sensitive. This one's highly sensitive. And we'll do the value function after we confirm this still works. And I do want to mess with the prioritize replay. We recover weighted importance sampling with alpha equals 0 and beta equals 1. Okay. But we need to look at this at some point then. It makes sense, I guess, that it did set this param to 0. Here. I want to see if it changes if I set beta equal to 1. Interestingly, 0 is a little worse than 0.1. Oh, no, the eval's the same. Okay. Logging differences. What happens if I set this equal to 1? That seems better. That is better. Yeah. And if I set it to 0? Literally doesn't matter. And then a value function coefficient. This one should have something to it, right? 5. Value function should have some sensitivity. Let me actually see what the range was from this. The value function in here. 1.1. Okay, this actually has some sensitivity to it, right? This performs substantially worse. Yeah, that's way worse. And then if I set this to like 2.5, Musingly still works very well at 2.5. But I guess it just can't be too low. Value loss gets clipped anyways, so that's probably what's happening there. Yeah, it works very well at 2.5. Okay, though, with all this, we have a good set of hypers. Yeah. We got a good set of hypers. So next, we will go to the maze, and we will see how the results over there are different. Oops. So this next env, can show it real quick. So this is Puffer Grid, the big maze environment. It will generate random size mazes from very small to the size of this window. And this is a very hard environment for RL. You can only see a small window around itself. This is generally a very difficult benchmark for RL to solve. But we've been getting very, very good results. And I can actually see that this kept running. Yeah, this is still running stuff. Cool. It did not crash. Even better. So now this is what we were more expecting, right? Now this, like, we actually get some way stronger looking dependence. So for a more complex env, it seems that we get a way clearer correlation with the hyperparams. And we see gamma here, we see our learning rate banded there. Learning rate's very different from breakout, but also the network size is very different. So lambda, value function, way higher. Okay, so this is actually in line with what we were seeing with the higher value function coefficient. Max gradient norm seem to matter. lower entropy. This is a super nice graph. We do go up and up in total time steps potentially here. Best results obtained at very small mini batch size. Interesting. We have our atom beta 1, which actually this is a different range than the other one. 8.7 for the best. And here this matters a ton, right? Look at that. The prioritized replay matters a ton. So that's a beautiful result right there. Okay, so far this sweep is like the best thing I could have possibly asked for. We're very happy with this. So we have these scores like this. Not very many good runs if you look at it in this way. We go on a relative time axis instead. Changes quite a bit. Where does it show priority buffer helps a ton? So what you do for that, Captain, is you look at these graphs, and then you look at, you plot on the x-axis the hyperparam, and on the y-axis the score. And then you can see across 170 some odd runs, the only good runs ever had very high priority alpha coefficient. You see? So this is one of the sensitivity analysis tools I like to use. Like similarly, right? You can see like the correlation here with like the value function coefficient, for instance. Now what we do is we go grab a few runs and we look more closely. Yeah, that's a new thing I added, Captain. I've been making progress. We've been making heck of a lot of progress in here. Better be with the amount I work on this stuff. I think this is going to take me longer than the next 35 minutes, though, to finish. We will see. So we need this brown curve. Yeah, we need this brown curve. Maybe this one we can just filter. Dude, this is literally reminding me of the the Uncle Bob, like, closure isn't fast. I was able to hit 20 frames per second on my little game I built with it. It's like, Neptune is really fast. It's like so many times faster than 1B. Yeah, it's still slow. Still freaking slow. And we should be sad that software is like this nowadays. Alright, so these are pretty nice. Why don't we, like, just tune this to, like... Perfect. 5 items. So these will be our runs that we use. It's 300 million steps of training. You can see we get pretty good performance in 200 mil. And on a relative time access, these are 6 to 10 minute experiments. Put sleep tariffs on Python imports. That's funny. You don't need, the sad thing is you don't need to put sleep tariffs on Python imports because some of them already take 2 seconds to import a damn package. It's like crazy that, like, people do not realize that software literally used to be 1,000 times faster. Like, I opened on brand new, like, Windows machine, highest end specs possible, open any application, takes 3 seconds. Open, like, brand new Mac, you know, open an application, takes 3 seconds. Like, it's ridiculous. 1, 2, that's at least better, but that's still embarrassing. Should be instantaneous. No reason it shouldn't be. 30 seconds if it's intentional software. No, it feels to me like most developers are trying to do that. Okay, so we get this nice band range here. Band range here. Very close gamma to what we happen to have for breakout, which is kind of interesting. And lambda. The tax for Electron is if you write an Electron app, you're just, like, banned from writing software because, like, what are you doing? You're just banned. Ah, shoot. You know, I didn't realize that we had update epoch set to 2. So I gotta rerun this sweep with update epochs 1. It'll probably be faster. Oh, actually, this looks like it swept update epochs. I guess this swept update epochs. Yeah, I think we just grabbed this policy to start with. We just, like, grab this policy, and then we go from there. Like, honestly, if I wanted to make a competitor to, like, either of these apps, Captain, I'd just be like, what if we wrote the front end in ArrayLib in C? Congratulations, all your stuff responds instantly. Almost as if you didn't need that massive stack of dependencies. There's actually like a kind of a crazy amount of there's like kind of a crazy amount of upside these days in just like knowing what you're doing and writing stuff super low level. Because like think about it, you're gonna be 1,000 times faster than anyone else. It's literally all I did with Puffer. Nobody else is gonna be able to like remotely do what you're doing because freaking nobody knows how to write anything that isn't like TypeScript anymore. So like pretty much no matter what you do in your fancy framework, you're never going to match perf-wise, and you're going to spend a ton of effort trying to match that perf. Kind of like a reasonable thing to do these days, especially with people like just making more and more bad software like quicker and quicker with AI. It's like kind of the way to go is to actually build stuff correctly, and then you get the massive quality difference. This is max. Too funny. This was actually only this is only 250 mil steps. I think it didn't even need to be that long, right? We don't forget update epochs 2. And then VF coefficient is massive. Massive value function coefficient. Cool. Don't think I forgot anything. I kind of just went down the line, so it should be good. Yep. Cool. So we will see whether this does anything interesting. 47 by 47 max size mazes. Rain, Neptune. So 80% solve. If you're assuming that you're always solving like the easiest, like the smallest mazes first, I believe 66% would be that you're solving always like 32 by 32. So this is better than an algorithm that just solves like 32 by 32 mazes. This is probably a very, very, very good agent. Kind of cool. Okay, so this is already at 0.7. That's kind of crazy. To have, this is 100 million steps, and that's like wrecking our previous best policy by a mile. And I should say more than this is just better than our previous best policy. I don't think anything else is remotely close on any similar task in RL overall. Yeah, this is a very good result. So I guess what I want to do while we're waiting for this, we got another 20 minutes. So this was the best one here. Best one had list learning rate. I'm just looking for like anywhere where one of these params seems like the other ones suggest it could be done better. Value function coefficient just keeps going up and up. Actually, it suggests that like the clipping param would be the one to look at. Max grad norm. Steps. The beta actually made a big difference over here, right? I do wonder if we increase this. The epsilon as well, interesting. Alpha. 0. Okay, so the two things I'm seeing potentially are the atom beta 1 and the clipping. Amazing RL. That's funny. So this actually does look like pretty stable training. It's not quite log linear. It does increase though. 0.8. 0.8 would be up to like 40 by 40 maps ish. on average being solved? Well, I guess it's actually a little harder to say. Because you can complete several short maps in the time that it takes like to fail on one long map. But this should be pretty cool policy to look at. Hey Tyler, welcome. We are analyzing a very large number of experiments. We got new hypers for breakout. We solve in about 25 seconds. And we have new state-of-the-art maze results. Maze being just stand-in ludicrously hard RL task. Well, should be state-of-the-art. We'll see when we look at this policy in a second. 82%. Very clean train curve. Any cool drone stuff on your end? On board? Oh, I see what you mean. Gotcha. Cool. Something similar. We should have something similar to Montezuma's Revenge. I mean, you could go implement it, to be fair. It would take a bit. I mean, honestly, like, just... You know who you should chat with? You should chat with Ryan. Because, like, Ryan wants to really get NetHack working. There are just some really obnoxious infrastructure problems with, like, getting NetHack to run really well. And the thing is, like, you're never going to make, like, a roguelike dungeon crawler type thing that's anywhere near the complexity of NetHack. But I wonder if, like, just the exploration part of NetHack, of, like, having to get through, like, a big roguelike dungeon, if we could add that to PufferGrid. It would just be, like, a new map gen algo, right? Like, if you made, like, interconnected rooms terrain gen algorithm, then instead of explore maze, it could be explore, like, maze of rooms or whatever. And then that would be interesting to see if you get, like, coherent room-to-room travel, just emergent. Like, it learns to never just run around in the middle of a room for no reason. Boom. Okay, well, that doesn't seem amazing, but this is a really unlucky seed. Look at this. You go down here, and then you're just totally stuck. Come on. There you go. Oh, that was good backtracking. The really long-term backtracking is still hard. This is like a really... Some of these bigger mazes have really hard seeds. Look, this one is all wrong, and, like... This one should be easy enough, right? It'll get this one, yeah. Scattered... This does actually have keys implemented, Captain. You can do locked rooms in this maze env. It'd be actually pretty easy to build stuff on top of this. I was trying to make, like, a... decent like grid thing without making it too engine-y. This policy can still definitely be better though. We can definitely still do better than this. Not bad though. It's just like sucks that it has to go all the way back here. It's kind of doing like local backtracking, right? Like it'll backtrack 10, 20 steps. But if it's on the other side of the map, it's just not going to do it. Like fair play, that's really hard to learn. Oh, wait, it got it. I didn't even see the solution. Nope, no reason, Captain. We should randomize it. I just haven't bothered. This is actually, if you want to do, well, you should absolutely get Impulse Force thing first, but like, this is a really good env if you want to like, just a solid research task. Like, this is a really good env to do stuff with. Okay, so I had a couple ideas with this. See what happens if I do this. It is possible the combination of very high value coefficient and clip is going to screw it up. I had some earlier tests suggesting that VF clip was set way too low. This curve seems to be very similar, though. It is somewhat disappointing. Hmm. What did we say this was? Prio alpha? Hang on. We had Prio alpha. Oh yeah, the atom beta. 0.92. I think I had something else for 0.99 was better for this. Let's try that. First of all, let's see, is this doing anything? Nope, same curve. So we don't need to mess with the value function clip coefficient here. We do want to mess with this optimizer coefficient. So we'll run this for a couple minutes, and then I will go grab breakfast, and then I will be back afterwards, and we will be continuing to work on probably getting a bunch of new sweeps launched, sweeps analysis, general cleanup, GPU drive, new M's. Captain, it would be a good idea to start getting Impulse Wars stuff training nicely in a release soon as well. We should definitely do that. Because, like, in my mind, we need good end benchmarks. We need good sweeps. I need to keep cleaning up the code a little bit more. And then we're pretty close to release. I'm just doing that stuff. It's a different one. Okay, this seems worse. It makes sense. You trust the sweep, right? If you do kickoff streams, sweeps on Impulse. Yeah, it's worth sweeping for sure. I don't know, it's pretty likely at this point that we just sweeping stuff kind of solves a lot of it. You know? It's fairly likely, I'd say. Okay. I'm going to go for breakfast, and I will be back afterwards working on all sorts of RL stuff for the whole rest of the day thereafter. So for the folks watching, this is all free and open source software. You can help me out for free just by starring the repo. Are we at 2K, or is it rounded still? I really would like to hit 2K today. 2 stars. If 2 people watching this star it, we'll hit 2K right now, which would be awesome. PufferAI/PufferLib on GitHub. Also linked from puffer.ai. If you want to get involved with development, join the Discord. It's discord.gg/puffer. It's also on here. And most of our top contributors came in with 0 RL background whatsoever. So we make it pretty easy to get on board, and it's a great way to learn stuff in AI and RL specifically. And other than that, you can follow me on X for more RL content. So thanks, and I will be back after breakfast, probably about an hour.